So once if the value of your r is less than 0, then you have to see that how far this negative value is from the lower bound, which is your -1. Okay, so here you can see that the negative 0.12 value is quite far away from your -1. So this thing tells me that the correlation between the two quantities that you have just calculated, that is this, is quite low degree, and you can say that the correlation between the two quantities is of inverse nature and is quite weak correlation. Okay, so you see also you can assert in a way that this is a low degree of inverse correlation. Okay, so this is a low degree of inverse correlation. All right, so this is it. So greater is the distance of the negative value from the lower bound, which is -1, then you will say that the degree of the correlation is quite low and it is inverse. So in the same way, if you're having r value, for example 0.89, you just calculated your r and it comes out 0.89. so once the value is positive, so you have to see its distance from the upper bound, which is your positive one, and it is quite small. Okay, the distance of this value, positive value, from the upper bound is quite small, so you will say that this is a high degree of direct correlation, because you have studied that if your r comes positive, if it is greater than 0, then this thing tells the direct correlation, and if the r value is negative, then this thing depicts the inverse correlation. And the degree actually we just assign by observing the distance of the r value from the lower bound and the upper bound respectively. If it is positive, you just calculate its distance, or you just examine its distance from the upper bound, and if it is negative, then you just examine its distance from the lower bound, and on that basis you just assign the degree, either it is high or low. Okay, so here you can see the distance between 0.89 is quite small from the upper bound, so you will say that this is a direct correlation of high degree. Okay, so that's it. Now move ahead to the line of best fit, and you have just studied how to establish the equation of the straight line by observing the slope and the y-intercept. So why there is a need of developing the linear equation of the line of the best fit? So it is because of that once the equation is so maintained, and we just form the general equation of that line of best fit, then with the help of that we can easily calculate the value of one quantity on the basis of the given value of the other quantity. Okay, so here you go. Okay, so you can see here that I have just maintained a scattered plot, a diagram. After that, I just draw the line of best fit that contains the maximum point on it, and the remaining points which are not lying on it should be as close as possible to this line. Then this line is said to be the line of best fit. Okay, so here I have just maintained line of best fit, and on that basis I'm going to calculate its slope and then the y-intercept by just extending this line onwards, and just see that where it is going to touch the y-axis, and then by calculating the slope value I just come to know the major equation. Okay, and in your slide you have just it is given to you that the line or regression line is expressed as y is equals to a plus bx. Okay, that's how it is maintained over here. So you can see that this is just another way of expressing your y is equals to mx plus c. So here you can see that this is your slope, it is behaving as m, and this is your y-intercept, which is c. Okay, so there's no need to get confused in that, just the representation has been changed, but the concept is there, it's the same. Okay, so once you are going to maintain the equation of the best fit of your regression line, this is something that you call a regression line, And once this equation has been formed, and you are going to have some numerical values of this a and b. For example, if I just say that over here somewhere, yeah, we have just maintained this equation, you can see. So over here you can see that the value of your b or m is -1 and the value of your a is set to be 6. Okay, so once if I just assign the value of your x, with the help of that you can determine the value of your y. So I just say that how about if my value of x is 50, then on that basis just tell me what is the corresponding value of y. So you just substitute the value of your x over here in the equation and you just get the corresponding value of your y. Because y is related to x, that's why I'm using the term corresponding. Okay, so it is going to be -44. Alright, so you see that's how the equation of the line of the best fit, that you call a regression line, helps you in estimating the other value once the value of the other quantity is given to you. Then on that basis you can determine the value of the other quantity. Okay, the second quantity. That's it. That's the reason of obtaining the line of the best fit. So as you can see in your slides, everything is so maintained here. This is said to be the line, the equation of your line of the best fit, that you call a regression line, and this is your b is the slope and a is the y-intercept. You can see here it's given to you, where a represents the y-intercept and b represents the slope of the line. And over here, if they have just calculated the a and b values here, then on that basis you can determine the value of your y if the value of x is given to you. Okay, so that's how the equation helps you.